Most of the division with polynomials is handled in a separate video, but we have an extra opportunity here to introduce something that works a little bit more quickly and efficiently for special circumstances. And that's when we have what we call synthetic division. If we divide by something like x plus a number or x minus a number, then we can more quickly work through the quotient and the remainder and overall do that division work. And that's going to end up being a whole lot nicer for us than having to repeatedly work out long division problems, which by nature are long. So what we've got is an example to illustrate the steps here. First of all, we need the particular components of this synthetic division procedure. And that's going to be the coefficients from our numerator. And we want to watch out if there are any missing terms, which is the same kind of concern that we've had with long division as well. If there were any missing terms, we would have a 0 in there where appropriate. In this case, there are no missing terms, so we would take those coefficients and write those in a row. From the denominator, we take the number that's after the x and we change the sign of it. And it turns out that we're going to put that number out in front, and we use what's essentially a very elongated L shape there to separate out the steps that we're going to work and the parts of this that we need to fill out. What we need to fill out here are these two empty rows that we've got pointed to here. And so here's how that goes. The first move is to take that very first number and drop it straight down. Now the rest of what we do is going to kind of have a sawtooth motion to it. What we're going to do is we're going to fill in the next blank, which would be right here underneath the -7. And once we do that, we can fill in the blank that's underneath of that. And then we can use this spot to help us fill in the blank that's underneath the -60. And then finally, the blank that is underneath that. So to work this little sawtooth motion and calculate those different entries, here's what we want to do. To fill in something on the second row, we want to take our previous bottom row times the number out front. So the blue 1 times the 5 give us this orange 5 right here. That's our second step. Once I have that filled in, to get the bottom row of all these other entries, I want to just add down the column. -7 plus 5 is -2. To fill in that next entry in the second row, I'm going to do a little multiplying. The number on the bottom times the number out front. -2 times 5 gives me that pink -10. I'm going to add down the columns. -60 plus -10 gives me -70. Because there are no other columns, I'm done with the work. And what I need to do is I need to take this information and build my answer. My bottom row gives me the two pieces of my answer. At the end of that bottom row, that aqua number that we've got there ends up being our remainder. And then we kind of work our way backwards through the rest of our information. In front of the remainder, we would have our constant term for the quotient. In front of the constant term, we'd have the coefficient of the x. If we had additional numbers, we would move to the coefficient of x squared, the coefficient of x cubed. And so other than the remainder, all of those other numbers are helping us build our quotient. So our quotient would have a 1 in front of the x and a -2 after it. So 1x minus 2 can be more shortly written as x minus 2. And to be as direct as possible, we're going to have our plus sign. We're going to put our remainder over top of our original denominator. So we put that -70 over top of our x minus 5, and we could call it a day. Yes, we do have a little bit of flexibility there. If we decide to we can get rid of that plus sign and go ahead and take the negative from the 70 and move it out in front of that fraction as a minus sign. But the most direct way of building that answer, like we had with our other long division problems, write down our quotient, write down a plus sign, put our remainder on top of a fraction bar, put our original denominator underneath that fraction bar. Done. So, let's do one of those together then. In this particular division problem, we've got a 2x power 4 minus 3x squared minus x plus 10. And even though it's not given to us in fraction form, this is going to be the denominator part. So we need to put together what we would have for our main part of this division problem, the number out front and all the numbers that are going to show up in that first row. The first things that we pick out are the coefficients from that numerator. So that would be the coefficients from this polynomial right here, 2x power 4 minus 3x squared minus x plus 10. And when we pull those coefficients, we want to make sure that we are careful about any missing terms. The first term that we have is a 2x power of 4, so the coefficient is a 2. After a power of 4, we would have a power of 3. There is no power of 3 that shows up. So, to have it stand out with my comment, there is no power of 3 on our x anywhere, so we need a placeholder in there. We need to register that we have a missing term. There is no x to the power of 3 term. There isn't one. Let's slap a 0 in there before we move down the line again to the x power of 2. Well, the x power of 2 has a coefficient of -3. The x has a coefficient of -1. And the constant term at the end is a positive 10. Out in front, we have to use the x plus 1. We're going to take and let's have a little fun and do purple. We're going to take the plus 1. We're going to change the sign. And that's going to go out front. Positive 1, change the sign, give us -1. -1 goes out in front. Now we've got the synthetic division set up, and we can start hammering out our steps. The first step is the easiest step. We take the very first number that is inside of our synthetic division setup, and we drop that bad boy straight on down. So, take the 2 and drop that sucker straight on down. The next entry that we need to fill in is right underneath that red 0. We're going to get that by taking the 2 down on the bottom row and multiplying it by the -1 in purple here. -1 times 2 is -2. We're going to put that -2 underneath the 0. In order to get the bottom entry, we take that column and add 0 plus -2 is -2. Sawtooth up to the next empty spot, which is in the second row. That means another little multiplication problem. I take the number on the bottom that I most recently achieved and multiply it by the number out front. So -2 times -1 gives me a positive 2. Add down the column. -3 plus 2 is -1. Take the most recent number on the bottom, multiply it by the number out in front. Negative 1 times negative 1 is positive 1. That gives me my entry in the second row. Add to get the entry in the bottom row. Negative 1 plus 1 is 0. Take the most recent number on the bottom, multiply by the number out front. 0 times negative 1 is 0. Add down the column. 10 plus 0 is 10. The easiest thing for us in terms of building our answer would be to start with the remainder and then work our way forward. That's the quickest way to figure out what kind of x and what kind of power goes with each of those numbers that's in that bottom row. So, starting with the very end number that's been bracketed off there, that's our remainder. In front of the remainder is a 0. The 0 is our constant term, which means it does not get any of our variable. In front of that is a negative 1. That's going to get just a plain old x. In front of that is a negative 2, and that bumps up the x to have a power of 2 on it. In front of that negative 2 is a positive 2, just because of the way that I'm writing it in here, plus 2, and this is going to have an x with, well, the next highest power is a power of 3. Now this is out of order from what we would normally see. So when we write our answer, let's go ahead and write that in the normal order. The quotient comes first, and the normal order for that quotient would be to start out with the 2x power of 3, followed by a minus 2x squared, followed by a minus x, and I do not need to include the 0 in there, so I go ahead and ditch that for the sake of brevity. The other part of my answer, though, is going to have the plus sign and my remainder over top of my original denominator, which would have been x plus 1 had they decided to write it in that fashion. So here we have our full answer from that division problem. Much quicker to have achieved that than by long division, unless of course you've gotten wickedly fast at long division. And this is still arguably faster and more efficient way for us to work out these special kinds of division problems. As long as, again, we have either x plus a number or x minus a number in our denominator, we can use synthetic division to work out more quickly what our answer is, quotient plus remainder over original denominator.